Hi everyone, so I'm here again to do a big overview of the networking part, right? So in my previous videos, what I did was I divided the networking overview, the AWS networking overview into 8 different sections or parts. But in this video, I will try my best to cover everything in one video. I really hope it doesn't go over 1 hour, but since the previous videos, each part was like over 10 minutes. So this one might be a bit longer, but I hope I am able to cover most of it. And then it's going to help you at some point that you might need help with, right? Okay, so I'm just going to share my screen really quickly and see what we have. Okay, so this is where we are. Just before I go, I wanted to make a confession too. So I am not a teacher. I'm teaching you AWS, and I am not an expert by no means. What I am is just a student who is learning AWS myself, and then trying to teach it at the same time, or kind of sharing my learning strategies with other students who might need, I would say, some kind of tips learning complex topics in AWS, right? So that's where I am. And so yeah, let me just get started. So, okay, let me see what I have. Okay, so that's okay. So this is the bigger picture, right? So we have the different components in AWS, and that's where I will be kind of ending it to this slide. So I will be covering each different part. And at the end of this, I would say this video, we will be able to have covered this entire thing. Right, okay, so let me see what I have. So we go through the part 1, and in this one we'll cover region, VPC, availability zone, private and public subnet, and internet gateway. Before I start, I'm assuming anyone watching this video have a little bit of understanding of AWS, right? So I won't be going into details. And even imagine you're someone who is completely new to it. I would say you will still be able to get something out of it, but you might be missing some, I would say, some concepts here and there. But the purpose for this one is to be for someone who understands it, and also for someone who doesn't understand. By understanding, I mean doesn't have a previous experience or kind of learning in AWS, right? So it's a bigger overview. Even being completely new to it, you will get some points that might be helpful. And then in the subsequent videos, I will be describing all the different concepts, each one separately. So this is a big overview, and I hope it's helpful for anyone watching it. Okay, so starting from a completely blank page, right? What do we have? We have a region, right? So let me just go to my previous slide. So in AWS, we have different regions, and in each region there are different availability zones, and within those availability zones there are different data centers, right? So we have region, within region we have availability zones, and within availability zones we have different data centers holding the data in all the different compute services, the storage and everything for different companies and organizations around the globe. So that's what it is. At the moment, AWS has around 26 geographic regions and then 84 different availability zones. And as you can see, in different parts of the world, and the orange ones are the ones coming up. And then the green ones are actually the ones that are the existing ones. Okay, so starting from a completely, I would say, blank page, what it is. Okay. So let's just drop a region here, another region, another region, another region. So maybe this is in United States, this is in Canada, this is somewhere in Europe, and then this region is somewhere in another part of the world. Doesn't matter where it is, but just dropping different regions around the globe in here, right? And then also adding a corporate data center in here. So we'll be seeing how we're going to be connecting our corporate data center to different regions in AWS. Okay, So we have a VPC. A VPC is actually a virtual private cloud, right? So we have anything that needs to remain more secure and private, we'll be putting that in an AWS, in an AWS VPC, right? And then what does a VPC mean if you have no understanding from before, right? Or even if you have and you wanted to have an analogy for that. Imagine a castle, right? So a castle is a huge, I would say, building, right? And it has a very strong and thick walls around it, right? So no one can enter it or no one can leave it without certain security measures, right? So imagine a VPC as a castle, right? So if you can't remember what a VPC does, imagine what a castle can do, right? Okay. So let's see what we have next. So I'm dropping an availability zone. So what is an availability zone, right? So again, in our castle analogy, it's a ward. And a ward is a specific, I wouldn't say a specific, but a part or a section or a portion in the castle, right? So it's just a ward where maybe like certain things are happening in the specific ward. If you have another ward, then other services or other things will be happening in that ward. And then, so I'm just adding another availability zone. Again, this availability zone would be another ward in a castle. So then we have a public subnet. So what is a public subnet? It can be a public chamber in a castle, right? So it's public because anyone will be able to access it. And then we have a private subnet in our availability zone 1, and then that would mean it's a private chamber where people from the outside will not be able to reach it no matter what. So they have to go through the public subnet and then through the private subnet, right? So it's subnets in here. So from the internet into the public subnet, into the private subnet. So the private subnet are meant that they do not have direct access to the internet or to the outside world. They can have indirect access through the public subnet and outside into the public internet. And the same goes for the private chamber. So anyone residing in the private chamber, they cannot have access to the outside world, but they can have access indirectly through the public chamber and outside into the world, right? And then adding, I would say another private subnet in there. Yep. So that's what I have. And then add another public subnet in availability zone 2, and that correspond to a public chamber in our ward 2. So just increase the size of the public chamber in here. So now I'm adding an EC2 instance, right? So an EC2 instance, just imagine if it's your first time hearing it, it's a worker that's doing some compute services out there. I really don't want it to go any further than this. So this is a worker that's doing some kind of compute services in the cloud. That's it. I think so at this point, that should be enough. And then I would say a counterpart in our private chamber would mean it's a secret wizard, right? So a web server being in a private subnet, we can consider that as a secret wizard in a private chamber, right? So that's, I would say, might be easier for you to remember. So if this is a secret wizard, might not have access to the outside world to talk to anyone, right? And then I'm just adding a MySQL database into my private subnet too, right? So this is the same thing, cannot access to the internet without going indirectly through the public subnet. And then just adding an application. So an application can be anything. For example, that can be a website they're hosting. For example, you can go with www.example.com or any website you're reaching out. So that application is residing in our public subnet because everyone is able to have access to it, right? And then a counterpart for our application is public minister, because the public minister is someone people from the outside can have direct access to, and then they can reach out to them. So and now adding something, if you want this this castle or this VPC, if it has to have access to the outside world, that access has to be happening through a port or through a pathway or through a gate, right? So in here in our VPC world, it's called Internet Gateway. And in our castle analogy, it can be considered our main main castle gate, right? So it's the main gate in the castle. Anything that going in and out, it has to go through that. I think so. I covered part one. It's pretty simple with or without previous understanding of AWS networking part. It's simple. You have a region. Within that region, you have a VPC. A VPC can be considered as a castle. Within the VPC, you have different availability zones. Availability zones can be different wards in a castle. And then within availability zones, we have subnets. And those subnets can be considered as chambers. So we have public subnets and private subnets, or we can say public chambers and private chambers. In anything that reside in the public subnet or public chamber, they can be accessed outside through the internet gateway or through the main castle gate. I mean, anything in the private chamber cannot be accessed to the outside world, but they can be accessed indirectly through the public chamber or through the public subnet. Okay, so I think so that's pretty easy. We covered up to this point. Let's see what we have next. Okay, so let me just go to my second part, right? So in this case, we are going to be talking about the internet access to VPC by the internet gateway, the NAT gateway, and the Bastion hosts. Okay, so let's see if again, if you're new to it or if you are you have some previous understanding, it will still make sense to you. So this is where we left off in the first part. So next, what we do is now this is imagine we have internet here, and then public internet, and then we have outside of the empire. What do we have, right? So anyone who wanted to reach through the internet into from the internet, right, into this public subnet, you wanted to reach out the application, right? They can do that, right? So the same goes from the main castle gate into the public chamber. So to the public minister, that's possible. They can happen directly. But if you wanted to reach out to the private subnet, you cannot do that, right? And here, and then if you wanted to reach out this other private, again, the private chamber here in our castle, no, that's not possible. And then if you wanted to, so if that's not possible to reach out here, so what we can do, so we are adding another, I would say, instance or EC2 that's configured as a Bastion host. And again, the Bastion host have the difference is has different security configuration, right? So because if the traffic is coming from the public internet and wanted to reach out to the web server, it has to become secure. And that's why it has to go through the Bastion host and then into our web server. So, and then I have another thing, I would say Bastion host here in our castle analogy as well. So it goes from the internet into the Bastion host and then goes into our web server. So this is how it's going to work. And then this is only for incoming traffic. So just remember, so if any internet, any traffic from the internet wanted to reach out to the web server, it has to go through the Bastion host into the web server. So that's for incoming traffic only. And then from the web server, so the web server can communicate with the database back and forth, right? So that's an easy thing. And again, about how these two communicate with each other, that part might be a bit more complex and complicated, which we are not going to go into depth at the moment. So just imagine these two can communicate with each other. So now let's see what else do we have, right? So in here, I just added another EC2 instance, and then our castle analogy, we can call it a treasurer, right? So a treasurer is just someone, again, in the private chamber that cannot be reached out from the outside. So it's just the same thing that I'm explaining here. I'm explaining it through some really simple terms, right? So again, the treasurer can be, so the secret wizard and the treasurer, they can talk to each other, right? but they cannot talk directly to the internet. And that's why we had the Bastion host coming through the secret wizard, and secret wizard is then talking to the treasurer, right, back and forth. So that's what is happening. And now what happens if this database wanted to talk directly to the internet? Can it do that? No, it cannot do that. In the same way, can the treasurer talk to the outside world directly? No, it cannot do that. So what do we have now is that, again, so we have this web server. Can it talk to the internet directly? No. Can our secret wizard talk to the outside world directly? No, they cannot do that. So what are we going to have now is adding something called a NAT gateway or a NAT instance, right? So the difference between a NAT gateway and a NAT instance is NAT instance, you can configure that and you manage the NAT instance, but a NAT gateway is managed by AWS, right? So it's an easy to instance again that's being configured to be more secure. And the main purpose for that is that anything that wanted to reach out to the internet, so NAT is for outgoing traffic only. So the database or the web server that wanted to reach out to the internet, how does it do it? It goes through the NAT gateway or through the NAT instance and then out into the internet, right? So, and then also if the database wanted to reach out directly through the NAT gateway and then through the internet gateway and out into the internet. In the same way, the Bastion host can also directly reach out to the database and then it reach out. So it reach out from the internet into the Bastion host into the database. So before I said it's coming from the internet into the Bastion host, into the web server, into the database, right? So that was kind of like 3 steps. But what about if I wanted to access database directly through the Bastion host, not through the web server? Can I do that? Yes, you can use the Bastion host to SSH into, or SSH is another way of saying reaching out or accessing this database. So from the internet into the Bastion host into the database, or from the internet into the Bastion host into the web server. For incoming traffic, for outgoing traffic, database talk to the NAT gateway or NAT instance in the public subnet, and then through the internet gateway outside through the internet. Same way, web server talk to the NAT gateway or NAT instance, and then through the internet gateway and then out into the internet. So that's what it is. And then if we just put something really simple here. So NAT gateway is for outgoing traffic. If you wanted to remember it, in simple words, you can say just imagine in a NAT start with an N. So it's kind of knocking out someone out of the door. So like anything that you wanted to get out from those private chambers into the internet, just knocking it out from the AWS network entirely, then that's where you use the NAT gateway or NAT instance. But if anything wanted to enter, that's where you use the Bastion host. But there is one little thing. So the NAT instance, not the NAT gateway, only the NAT instance can be configured to act as a Bastion host. So the incoming traffic and outgoing traffic can go through the NAT instance, but not NAT gateway. So only NAT instance can act as a Bastion host. On the other hand, the Bastion host can only act for incoming traffic. So that's my understanding up to this point, right? So I have been learning it through different Udemy courses, WizLab, and some other online platforms, that this is how a NAT gateway, NAT instance, and Bastion host work, right? So my understanding is up to this point, there might be different purposes for these services, but up to this point, I think so I have what I have learned so far. So I'm sharing what I have learned from those courses so far. Okay, so let's see what we have next. Okay, I think so I'm almost done for my second part, which is 2.1. And now I will be going into 2.2. And then in this one, we'll be talking about the VPC subnets, right? VPC, yeah, and then subnets and CIDR ranges, right? Okay, so let's see what we have. I think so. Did I make a mistake saying VPC and subnets? What I meant was VPC subnets and CIDR ranges. But anyways, I might have made a small mistake in here, but the main thing we will be covering CIDR ranges in this one. And let's see what is a CIDR range, right? Okay, so let's just have a VPC in here, and then in this VPC, we're adding a public subnet, a private subnet, and then adding some EC2 instances into those, let's say subnets, right? So then we're giving a number. Just imagine this is a number that we're giving it to this VPC, and then in layman's term, or in, I would say in the ways that we can understand, let's imagine this is a phone number for your house. So a VPC, this is your house, and this is the general phone number for your house. Or if you think this is a building, right? So this is kind of like the number for this building, for this entire building. And then you have different floors, and then within those floors you have different, I would say, units or apartments. And so those are those different units in apartment. So a building can have one general phone number, and then different, I would say, floors can have different numbers, and then certain units within those floors can have different numbers. Or I think so this building analogy might not be helpful. We can think of that as an organization, right? So you have your company, right? So you have a general company number, and then you have different departments. So the public department can be that communication department that can communicate with outside world, and then you have the private department where people don't talk to the outside world. So and then they have different numbers. So I'm just giving them some numbers. So you have a general company number, then you have specific department number, and then within those departments, you have specific offices, right? And then those offices will have their own phone numbers, right? So I hope it kind of makes sense to you, the general building number. But now, how did we come up with this specific number, right? So let me just go a little bit. So if you have, I would say, an IP range. So this is an IP range or CIDR range, right? So it's 10.10.00/16. So this is an IP range. And then this thing in blue is actually the prefix or subnet mask, right? So how do we come up, or what do these numbers actually mean? So if everything is 0, that means it's out to the internet, and all those digits can change, right? And by change means these digits, you can put any number in here, and that might correspond to a certain IP for a certain device out there in the internet, and that's how you want to reach out to it. So for example, if I'm putting, this database wanted to reach to the internet here, right? So this means, so I wouldn't call the database because database cannot reach out to the internet directly. So I will say if this application in here, the public subnet want to reach out to the internet, then the IP range that it's trying to access will be this thing. And then from there, it will be more specifically routed to a specific device that has a specific IP, right? Okay, and then so if it's a /8, this means only the last 3 digits can change. And then if it's /16, only the last 2 digits can change. And if it's a /24, only the 1 digit can change. If it's /32, no digit can change. It means it's only a single IP. Again, how we come up with those numbers, I will have a separate video on CIDR ranges just to explain how we come up with those numbers. But for now, if you're using these numbers, you can understand to a certain extent what do they stand for. And there's a simple formula for that. So 2 to the power 32 minus the prefix, right? So if the prefix in this specific example is 16, and then 2 to the power 16 is almost over 65,000 different IP ranges. So if we give this specific /16 range to our VPC, this means up to 65,000, over 65,000 devices in this VPC can have IP ranges. So you can go with up to over 65,000 VPs in this specific VPC, right? And then you wanted to further divide that into parts, right? So the /16, and you can see for a subnet is /24. So always and always, the bigger those numbers, the more specific they are. The smaller those numbers, the wider they are. So they cover much more bigger range as compared to this one. So for example, imagine if we, instead of 32, we wanted to put 24, then that will be a smaller number. So 2 raised to the power a smaller number, then this IP range will be much smaller, which means this is a smaller prefix, a smaller range as compared to a /16, right? So /16 is more, I would say, wider range, and then a /24 is more specific, hence more smaller range. So let's see what we have. So I'm just doing this thing to make it a bit more easier. For example, if it's a /32 2 to the power 1, like putting this in thing, this prefix into this formula, this is how we come up. For example, if it's /26, it allows only for 64 IPs because 2 to the power 6 is 64. If we have a slash, I would say, 24. Then there will be a 256 IPs because 2 to the power 8 is 256. So on a subnet level, right, and this specific subnet has a /24 IP range. This means there can be up to 256 IPs. So up to 256 IP ranges can be accommodated in this specific public subnet, right? And then the same goes for this one. So within, for a VPC, the last /16 means the last three digits can change. So for example, if I'm putting this one into the subnet, I'm giving a part of this IP range to this subnet, then I can only change the last 2 digits and see how I'm changing this one. So for this one, I'm changing this, I'm not changing anything, so I'm just putting the 0, and then for this one, I'm changing 1, right? If I'm going to add another subnet, I can put 2 in here, and I can put 3, but I cannot touch these first 2 digits, right? So these first 2 digits cannot be touched, no matter, so 10.0. This cannot be changed, but the last 2 coming from this /16 can be changed. Now, further, if you wanted to give a specific IP to this EC2 instance, right, inside my public subnet, then what can happen? Only and only the last digit can change, right? So for example, if there is an EC2 instance with 10.0.0.1, the other one can be the last digit in here can be 0.2, 0.3, 0.4, and further on, right? And then also, if you look into this one, I'm not being able to change 10.0.1, and then this thing can change like 1.1, it can become 1.2, 1.3, but whatever these digits are in the subnet, they take the same one, but only the last digit changes. And this one too, they take the entire thing, kind of they inherit the entire thing from their subnets, but only the last digit can change, right? On a VPC level, the subnet inherits everything, but only the last 2 digits can change. On a subnet level, if an EC2 is getting an IP, then everything can change, inherit everything from the subnet, and only the last digit can change. So I hope it's kind of making sense. Let's see what we have. So I got rid of those other information. So I can say, yeah, again, a CID range can be a phone number that you can give to different things. You have a company, there's a main general line you can reach out to a specific department. And within those departments, you have certain offices that you can reach out to. So this is how it is, right? So I'm just adding a few more, I would say, subnets, some EC2 instances, and then let's see if we add more EC2 instances in there, giving some more IP to them. So now see how it makes sense, right? So again, this EC2, and this EC2 instance, they're all inheriting, I would say, the first, how many digits? So 1, 2, and then 3, right? So that all the 3 digits they're inheriting from the subnets, and only thing can change is the last digit, right? So if you can see that, this the last digit can change. So 0.1, 0.2, 0.3, and for this one the same goes, only they're taking everything. So it has like 10.0.1, and this one 10.0.1. So this thing is inherited from their subnet, and the only thing can change is 0.1 then, right? And then also the same goes from this 1.1, 1.2, 1.3. And then for this one, since the subnet has a 10.0.2, inheriting the first, I would say 1, 2, and 3 digits from the subnet, and then only this one can change. Okay, so this is 2.1, 2.2, and then we have the last one as 2.3. I really hope it kind of makes sense. But now we just drop a few phone numbers or CIDR ranges for our VPC, right? So here you go, we're just giving some numbers in there, but I'm hoping that it actually did make sense. So I think so we did cover the CIDR ranges for this one. So that's all for this part. Again, the next part that we'll be starting is AWS Networking Part 3. So let's go with that. What we'll be covering for this one is security groups, NACL or Network Access Control List, VPC route table, auto-scaling groups, application load, and application load balancer, right? So again, if you're new to this concept, to these concepts, it's still okay. You will get a bigger idea of what it is. If you have some previous understanding, it's even better, right? Okay, let's go with this. So this is where we left off from the previous part. Now I'm getting rid of all the CIDR ranges, now coming back to this region with a specific VPC, right? So adding some more, I would say, EC2 instances into this public subnet, and then also giving some, since they're in public subnet, they will have a public IP address, but if they're in private subnet, then they will have private IP addresses. Now we're coming to the concept of a security group, right? So again, if you take this an example of your, I would say, your castle, right? So this means then this will be, this is your ward, this is your chamber, and then this is a room inside the chamber. If you want to take the example of your house, or maybe like a company, then you can say, so this is the entire big company, then this is a specific department, and within that department, there is an office, right? So the people sitting inside the office are actually EC2 instances in the security group, which is a security wall. Around this EC2 instance is actually a room or an office, right? Okay, so I'm adding an EC2 instance in here too, and then we can consider this, yeah, as a secret room. I wouldn't call it like a secret room, but the thing is, again, even if they are being in a public chamber, right? No one from the outside can reach out to them if the ports on the security group or the port on the security layer or security wall allow for that, right? So even being in a public chamber or a public subnet, if the route on the security group or the port on the security group doesn't allow for the traffic, they cannot be reached out. So that's what it is. Okay, so now, and then we have the network access control list. So the security group was at the level of the EC2 instance, but the NACL or the network access control list is at the subnet level. So if you can see this purple dashed line or a rectangular kind of like wall around the subnets, that's where the subnet work. For example, any traffic that wanted to reach out to the subnet, they first have to go through the security of the NACL, and then they have to go through the security of the security group, and then they have to go through the EC2 instance. For example, if any of the traffic is banned at the NACL level, it cannot reach out to the security group. And then even if it reach out to the security group and then it's banned at the level of security group, the EC2 instance cannot have access to that either. So that's how it works, right? So the same goes, that can be like a chamber wall or a security wall around this public chamber, inside which we have our secret or secure room. Right, so I think so I misspelled it before. It's actually a secure room rather than a secret room. So it's a secure room. Okay. Yeah, so here you can go. So traffic coming from the internet first have to go through the NACL, and then it has to go through the security group, and then it reach out to the EC2 instance in there. Next up, we are going to be talking about the route table, right? So route tables, consider them as like registers that has the information about the different traffic in and out, right? So anything inside wanted to reach out to the internet, what they do. Anyone from the outside, they wanted to reach out inside here, how do they do? So it's kind of like a routing information for that, right? And then, yeah, so it's a route registry. For example, if you go through the castle analogy, so anything that's meant for this VPC, which is kind of like the phone number for this VPC, has it's kind of local, right? So anyone inside this castle, they can talk to each other, and anyone inside this VPC, they can reach out to. So for example, if their destination is this, it's local, means anyone talk with each other. If the destination is kind of like 0.00/0, which means internet outside, it goes through the internet gateway. And then, for example, if it's 10.0.2.1, right? So let's see, where do we get that? And I said it's through the Bastion host, right? So this is our web server. So any traffic, say, that's coming from the outside and it's meant for this web server, in the web server being in the public subnet, in the private subnet, my apologies, it means they cannot be reached out directly, so they have to go through the Bastion host. So it's me sitting outside and I wanted to reach out to this web server, right? What I do, I go to this route registry, and then I look into where I'm going. Oh, I have to go through the Bastion host. Okay, then first I go to the Bastion host, I ask for their permission. If they're going to allow me, then I'm going to reach out to the web server in this private subnet. So this is how a route table works. So actually, whenever the internet comes through the internet gateway and then it reaches out a router, then a router has a route table. So the route thing will come up later, but from the internet gateway into the router, in a router has a route table. And the route table has the information about the different routes. How do we kind of direct the different traffics coming in and out. Okay, so I think so that was the concept of the route tables, right? So now I added an auto scaling. Again, if you're new to the concept of auto scaling, it means this, right? So you have one worker. So I call the EC2 instance or the compute service as a worker, sitting out there doing some stuff, right? So if the workload increases, right? So what do? You have to manually spin up another EC2 instance, or you have to manually start or deploy another EC2 instance. But if you're using auto scaling, they can detect the workload. If the workload is more, they can spin up more EC2 instances, or they can deploy more EC2 instances in this public subnet. If the workload is low, then they can shut down some of the EC2 instances, then you will have fewer. If workload is more, for example, you can have 4 more EC2 instances. This auto scaling will do that automatically. But if the workload is lower, they can come back to the one, right? So then you can have a specific number. For example, my CPU utilization, if my CPU utilization is 50%, add 2 more instances, then we will have 3 instances in here. But if my CPU utilization is, say, 80%, then spin up, I would say maybe like 5 more instances, and there we will have 6 instances in total, right? And then by CPU utilization, mean the CPU utilization of each specific, I would say this EC2, for example, this EC2 is working, CPU utilization reach 50%, this means you add 2 more instances. CPU utilization for this EC2 instance reach 80%, then you kind of put 5 more, then you have 6 in total. EC2 instances. So this is how auto scaling works. Again, I will be talking about this concept later on when we talk about the compute services. But for now, this is how it works. Okay, so now we talk about, we added the application load balancer. So now if the traffic is coming from the outside, right, and you wanted to load balance it between kind of EC2 instances in this subnet and also the EC2 instances in another subnet, right? In another availability. So you have one availability zone and a subnet in here, then you have another availability zone and a subnet here. And if you wanted to load to yeah, to load balance the traffic, then you're going to be using application load balance, right? So we have different, so they're actually, the main concept is, I would say, the elastic load balancer, right? And then within the elastic load balancer, you have three different types. So one is application load balancer. The other one is network load balancer. And then we have classic load balancer, which is an older version of it. And I'm probably thinking they might not be in use anymore, or kind of companies wouldn't want to use it because they have the newer versions in better versions, why they would go with a classic load balancer. And then they also have a gateway load balancer. So 4 in total, so I see 3, but like the gateway load balancer was added later on. So we have application load balancer, network load balancer, gateway load balancer, and then we had classic load balancer, right? So classic load balancer might not be used in anymore, but now what each one of them do, we will be talking about them in a separate video. But at the moment, just consider they're kind of load balancing the traffic to different workers or to different EC2 instances in this case, right? Okay. So that's, I think so. Now let's see what happens next, right? So the traffic is coming from the internet into the application load balancer, and then coming to this EC2 instance, and then also dividing into this one. So I say I want to send 50% of the traffic here, 50% here. This is how it works. Okay, so I think so we almost finished this part. So our next part will be part 4. So I hope it kind of made sense up to this point, right? So we talked about, I would say, the security groups at the level of EC2 instance, network access controllers at the level of a subnet. And then we talk about the auto-scaling group. We talk about the kind of increase or decrease the number of EC2 instances based on the workload, and you talk about the application load balancers, which divide the traffic onto different EC2 instances based on the percentage that we define. Maybe like I want to send 20% here and 80% here, that can work out as well. So that's it. Let's go for the next part. We have part 4. Okay, so I think so our last part was, we had 8 parts, so we're almost halfway through it. Now this is a very, I would say, interesting part that we'll be covering. It might be a bit confusing, but I'm really hoping it kind of makes sense, right? Because yeah, let's just work on it and see how it makes sense. Okay, so we are going to be covering Route 53, and then also what is a private and public hosting zone within the Route 53. We're going to be covering Cloudfront, edge location, regional edge location, S3, and also origin access identity, bucket policy in web application firewall or WAF, right? Again, you might be new to those concepts. You will still know at the end of this part what's the main purpose of those services, or what they actually do. For example, if someone asks you what a web application firewall does, in one sentence, you would know what it's going to be doing, right? Okay, so this is where we left off from the previous video. So now imagine we have some users, right? So they are trying to reach out our services inside our VPC. What's happening? So a user sitting on their computer, they're going to be typing this domain name or this URL, www.example.com, right? What happens is it first go through the Route 53, right? And what is the Route 53? Route 53 is like a phone book, right? So for example, you wanted to reach out someone and you don't remember their phone, and then you're kind of in old times. Instead of your phone contact list, you go through the phone book and you see, okay, that's the name of the person and that's their phone number, and you reach out to them. Or maybe kind of like can think of yellow pages, right? So you have the name of a kind of like an organization or a company, and then you have their phone number. Okay, so if this is ABC company, that's their phone number. This is XYZ company, that's their phone number. So basically, the DNS service or the Route 53 is actually a DNS service for the for AWS, and what it does is it has the names it has the domain names and it has the IP addresses, right? So if you give this specific, I would say, URL, it will look up and find what IP address it corresponds to. And then based on that, it kind of routes you back that, for example, if this example.com was the domain name for this application and here, then we are going to be looking for a specific IP address that this application has, and then we'll be routing it to that, right? So I'm a user, I'm typing this into my browser. From the browser, it goes into my Route 53, right? So it goes to the Route 53, and then Route 53 is going to send me this thing. So 10.0.2.1, this means I'm trying to reach out this web server. So I wanted to do something with this web server, so it's returning me this IP address. And then once this IP address is being sent to me, and then through that IP address, I will be able to reach out to this web server, right? And again, what happens, again, if you might not be able to be reaching out directly, we might be doing that through the Bastion host and then into the web server. So this is an example. I would really not want to go into this one because it's a bit complicated, but I will have the slides available, and anyone want to look into it, they can do that. There's basically like the difference between a cloud, like what the Cloudfront is doing and what Route 53 is doing, or how the traffic is being sent from the user to the Cloudfront into the Route 53. So a user can reach out, can access services within a VPC or AWS region through the Route 53 directly. So from the client to the Route 53 and then into our kind of AWS region, or they can go through the Cloudfront and then to the region. So let me show you what I mean. For example, like this Route 53 can directly reach out to these regions, right? Without Cloudfront, right? So what can it do is like it can go through the Cloudfront. So I didn't mention what a Cloudfront is up to this point, but let me just put it here right now. So here you go, you have Cloudfront. In the Cloudfront, imagine this as an express delivery, right? So you wanted to deliver your content really, really fast, right? In a more secure way, then what you do is you go through the Cloudfront. So like, as I said, a user can go through the Route 53. Route 53 acts as a phone book, looks up the domain name that corresponds to a specific IP address and route that to that specific service that you wanted to reach out to. But if you wanted to go through the Cloudfront, it might make it more faster for you, and then it will make it more secure. And why it does that, like how Cloudfront make it more, I would say, faster for you. And the reason for that is it has something called, I would say, edge locations, right? I can see like I dropped these WAF in here, but I'm going to talk about them later. But at the moment, just think about this one. See this part. So edge location and regional edge location, right? So imagine there is, I also dropped S3 in here. So S3 is considered that just as a storage in the cloud. And then in that storage, you have something that you wanted to access, right? So if I'm a user, right, and I wanted to access something in this S3 bucket, I first am going to check out the edge location. If that thing is available in the edge location, I don't need to go through my origin, which is S3. In an edge location, consider that is kind of like a mini station that's holding or that's keeping more frequently accessed items ready. So for example, if there is a certain website that's being frequently accessed, or a certain item or a photo, for example, that's frequently accessed from this S3 bucket, so it's being ready in here, and every time a user is trying to access it, they are not routed to the origin, but they're being just routed to the edge location. You get it from there, and that's it. So, and then if the edge location doesn't have that item, they go and they check out the regional edge location, right? So at this specific region, there is a regional edge location, and they look into it. If it's not there, then it will go to the origin. So maybe like this S3 bucket is actually in this other region, right? And then since the S3 is here, and then they have a regional cache, regional edge cache right in here. So it's going to keep bring the content from this region and put it into this regional edge cache, and it's going to look for it in here, right? So this S3 bucket can be in the same region, at which point you don't need the regional edge cache. You just have an edge location and you get that from that. But if it's in a different region, then you have to have like a regional edge cache where you have then you can get those contents from there. So like what happens is usually the Cloudfront is meant to have different edge location around the globe, right? So you have like your main origin, and then you have different, I would say, many stations that you can access. You can have frequently accessed item into those regions, and then you can access it from there. So you don't have to go through your, I would say, origin more directly. So let me just go through something, right? I know this topic is a bit confusing, or I made it confusing, I don't know. But I want to do something. So I wanted to put regionals. I can put this thing, Cloudfront regional edge cache, right? So let me see if I can find an image that's more easily to understand compared to what I had there. I was kind of thinking to access it that way, but I think so I didn't do that. So let me just go through this one. I hope it kind of makes sense a little bit, right? This one is not that good. Let me see this one. Okay. You can go through this one. This one, I think so it kind of makes sense as well, right? So if you look into this one, so imagine there is an AWS service that you wanted to reach out. So first, what you have is you have regional edge cache, which is kind of like the bigger cache, right, at the regional level, and then you have edge locations, which are a bit smaller, and then you have your viewers who are trying to reach out to the services. So this viewer can come to the like edge location. If the item is not found there, then you go through the regional edge cache, and if it's not there, then you go through the origin, right? So this is one thing. Let me see if this is a good one or this one. There was a really nice one that I try to have. Maybe let's see this one, right? This one might be a good one too. So like here is a kind of you have a S3 or EC2 instance or any kind of service you wanted to access, right? So you have your regional edge cache and you have your edge location, right? So the item is being cached up at the regional edge location. So this user that's trying to reach out to this edge location, right? It's not found there and goes through the regional edge cache. It's not found there, then goes through the S3, right? So once that photo or that item is being accessed by this user, a copy of it is being kept at the regional edge cache. So now if this user is going to come and they cannot find it at their own edge location, they come through the regional edge cache. They see it because it was accessed before by this other user. So now this user can have access to it because it's being accessed before, it's being kept here. Now this person is going to get it. That's why it make it faster, right? It's because you have those many stations that kind of keep frequently accessed items that other users, when they come, they don't have to go all the way to the origin. They come to a regional edge cache location, and that's where they get their item from. And this is how I would say the Cloudfront is going to work in terms of making it a bit easier for the users to get those things. And the kind of this one is the same concept, right? So I won't go into that one anymore. So I think so it kind of made sense to you, right? Okay, so let's see, what's this one? This one is kind of a bit blurry, right? But I think it kind of makes sense if you see it here. So before previous architecture was actually everyone was trying to access the origin. So maybe like the traffic, it was like an overload traffic at the origin. But now what happens is like origin is serving content to regional edge cache location, and then the viewers or the clients are accessing them from the region from the regional edge cache, they don't have to go all the way to the origin. It's kind of offloading the traffic to the regions, to regional edge cache, and that's how it kind of make it more faster. How about this one? Let me just talk about this one too, right? Because I did mention like how user can go through the Route 53 through the Cloudfront and here, right? So it can go through the, I would say, directly to those like users through the Route 53 can directly access the, those origins, like maybe S3 or EC2 instances, or they can go through the Cloudfront. If it's through the Cloudfront, it's going to be more, I would say, more faster and more secure, because Cloudfront has some security attached to it as well, which I might be explaining it in a different video, not at this one. So, okay, so for this one, if you can see in here, they have like the VP dash thing, like content slash star. So anything that have this specific URL, right? Like at the end, for example, you might have a main URL and then you have this part attached at the end of a URL, right? For example, like in here, you can have like google.com and then this part. If the URL has this specific part in there, then it's being routed to an S3 bucket. But if it's kind of a login thing, kind of more an interactive session, it goes through an EC2 instance, because the EC2 instance is actually a compute services. It's a worker, it's doing something, but you have some static content like photos and kind of static web pages is kind of resides in the S3 bucket. And that's where it reaches out. Kind of like once it goes through the Cloudfront, how does it know it has to go through to an S3 bucket, or how it can go through an to an EC2 instance? For example, in this one, right? Let me just go like quickly full screen on this one. So I say like this user, once it goes through the Cloudfront, how it knows that the Cloudfront should send it to an EC2 instance here or to an S3 bucket here. It kind of depends on the URL. So like the sub part that you have in your URL, if it's something like has a content slash star, it goes to an S3 bucket. If it has like kind of like a login and admin kind of thing, you are a part, like sub part of the URL, it might be directed to an EC2 instances through some loads, through some type of load balancer, right? So I think so this concept of a CloudFront kind of routing the traffic was kind of clear a little bit, right? So let me see what do we have in this architecture in here. So we have an S3, we have a user, we have an S3 origin, and then we have a CloudFront. I'm assuming this is a bit more complicated at this thing. Yes, we do have a regional edge cache, we have edge location and everything. But at this moment, I would say this is a bit more advanced level than what we had before. So, oh, this was a really nice one. I think I was looking for something like this to explain how the edge location work, right? So like, I think so we did get a point of how it looks like, but here it is. We have an S3, which is like in this specific part, maybe EP South, kind of something region, somewhere in here, right? And then you have some users in, say, South America, you have some in North America, you have some users in Australia, you have some ones, I'm not sure is it China or which part it is, but a bit maybe like Europe. Who knows? Okay. My apologies if I'm not that good in geography kind of, I would say, terms, right? But anyways, that's not the point. The point is I have an origin here. So this user is going to access something through the S3 bucket. And then that's being, a copy of that is being cached out in this region. And then now if this user is going to try to, another region is, which user is going to reach out, is not going to go through the origin, will go first go through the, I would say, through the specific region, and not region, the specific edge location, and they will access it through it, right? And then also, for example, since this thing was being cached out in here, or maybe I would say it in this way, right? So here I have an origin, right? Let me just rephrase everything I said. I have an origin here and I have a specific edge locations in here, right? So it works this way, right? So we have, I would say some users in here, they kind of reaching out to the origin, but then we have some caches in here. So once this one specific user reached out to the origin, that item was being cached out here. Now this other one doesn't go again all the way across the ocean to this origin, because the longer the way, the more latency it will have, right? And it will not be fast. So it's not going to go all the way to the origin. This third user is going to access it from this cache, right? So this is now, these are the regional edge caches. This is my origin and these are users. Once being accessed by one user, it's being cached out at the regional edge cache. And then what happens is that the other users doesn't go all the way to the origin. It goes back to the edge location and get it from there. So I hope it was kind of clear, right? Okay, so this is a nice, let's see, architecture as well. And the reason I'm going through more architectures, because it's a nice way you will get it better as compared to just one, I mean, my PowerPoint that I had, because these are more nicer, more beautiful as compared to what I had, right? I think that this is a really nice one. So like it's a Cloudfront architecture, right? So what you have is you have your edge locations, the smaller ones in here, and then you have your regional edge cache, right? So the first what happens is this lady or this girl is checking out the regional edge cache, right? So if it's not there, then it's going to check our regional, this kind of our edge location. If it's not there, it's going to check our regional edge cache. And if it's not there, then it's going to fetch that photo all the way from the origin. And now this photo is being sitting down in this regional edge cache. Now another user is coming along, right? And then they check the edge location. If it's there, they access it from there. If it's not there, then they go to the regional edge cache and they access it from there. So it's kind of offloading most of the traffic, I would say inquiries, not the traffic, I mean, most of the traffic that's going to the origin. So if everyone was trying to reach out to this origin, there will be so much traffic on the origin, but since they're getting the their item or their content from the regional edge cache or from the edge location, it's going to be much more easier. So this is a really nice diagram, right? So I would even wanted to, I'm not sure, copy this thing and paste it into my PowerPoint, because it's a really nice one. Maybe I can just simply do that, because it kind of clears everything in a very nice way. I will do that really quickly. It doesn't take your time. Let's see. And then I will be sharing this thing, excuse me, these PowerPoint slides with you guys, so you know what I'm doing. Okay, so that's okay. So let's just go back to where we're going, right? So this is where we are. I'm going to make it full screen once again. We talk about the concept of the edge allocation and regional edge. I think so really hope was clear enough. And then the only other thing was the web application firewall, right? If you do wanted to make this access more secure, so you add the web application firewall to it to make it more secure. Again, that will be like some more security adding it to this to the users accessing through the Cloudfront or and then through the S3 and then through the EC2 instances. I won't go into details about the WAF, but you can put the WAF between the user and the Cloudfront, and also between the Cloudfront and the internet. So two different to make it more secure. So first, it's me accessing the Cloudfront. In between, the WAF is coming, and then the Cloudfront accessing the EC2 instances or the S3, another WAF, right? So like putting WAF at two different stages, between the user in the Cloudfront and between the Cloudfront and then the origin. It's kind of making it more secure. So I hope this is making sense, right? So let me see. Yeah. So this is again the concept of the users reaching out to edge cache. I won't go into these ones because you did get the point, right? So like, for example, if a user is trying to directly reach out to the EC2 instances, they cannot do it. They have to go through the Cloudfront. And also, if the user is trying to reach out the S3 directly, it cannot do it. It has to go through the Cloudfront. There's an option where the user can access the S3 bucket directly if the S3 bucket is, I would say, public, and if the user has the URL for the S3 direct. If the user has the URL for the S3 directly, that's when users can go through it. Can access it. But if I have configured my S3 bucket through the Cloudfront, right? So, and then my users have to go through the Cloudfront and then to S3. And how does it work? So we have something called origin access identity in an S3 bucket policy, right? So if you don't know what those terms mean, it's a simple way of saying that I'm configuring my S3 bucket in a certain way that the user cannot access it directly. The only way for them to access it, they have to go through the Cloudfront. So that's the main purpose of it. But again, how they work, I'm going to be having like more videos on more specific details of them. And then I have, we did talk about the Route 53, but we have something called private hosted zone, and we have a public hosted zone. Again, the way we talked about was Route 53 is like a phone book, having the names, corresponding phone numbers, having URLs or domain names, corresponding IP addresses, right? So if it's a public one, this means, so anyone from the outside is trying to reach out to services in the public subnet. That's where all the information, the domain names in the IP addresses will be in public hosted zone. But what if this database wanted to talk to this web server, for example? In that case, then we're going to be having private hosted zone. So say, for example, this database also have a domain name. So that can be like www.example.com/db, right, for database. In this case, this web server has the name of the database, in which case is the domain name for the database, but it doesn't have the IP address. So what the web server does, it goes through the private hosted zone, looks up www.example.com/db, and then the private hosted zone is returning the specific IP address, and then it goes through that IP address. So this is how a private hosted zone works. So imagine the private hosted zone is a private phone book, right? So only internal people are using it. And then public hosted zone is a public phone book that anyone from the outside they wanted to access the public services, and here they can do that. So that's, yeah, here you go, like this is how I have it. And here, and then Route 53 is like a phone registry or a phone book. Okay. Yeah, and then we have private zone registry as well. The concept for the Cloudfront can be like an express delivery system, and then the edge location are express delivery stations, and then the history in simple terms can be like a public storage. Okay, so that's I think so that's a good amount of stuff that we did cover, right? So let me look into my timing, what time it is for me. How do I look my time? Anyways, whatever time it is, I might have like a few more minutes to go through it, right? So what we covered was, in this part, we covered Route 53, we covered Cloudfront, we covered how edge locations work. And then what else did we cover? I think so that was a good thing we covered about WAF and everything. So here you go. The next part for us is going to be, so thank you for this part up to this point. And then next up we have part 5, right? In that one we'll be covering VPC endpoints, VPC interface endpoint, and a private link. Again, even if you're new, at the end of it, you will know in one sentence, what do those services do? So this is where we stopped before, right? So I'm just moving my cursor a bit to the right. To make some space, I'm adding one more region in here, and then within that region, I'm adding a VPC. In this case, I'm calling this a service consumer VPC because it will be accessing some service from another VPC, which is called a service provider VPC. Now, if these two VPC within this region wanted to access content from each other, right? How does it work? So I'm adding an availability zone, a public subnet, a private subnet, and then what else can happen? So I'm adding some EC2 instances in there. These EC2 instances are not shown to be in availability zone or subnets, but they actually are. So for the sake of space, I am not adding those extra stuff in there. But you get the point. So EC2 instances always have to be in certain availability zones and certain subnets and things like that. So now if this EC2 instance wanted to access some services from this VPC, how does it do it? It happens through something called private link, right? And then always there should be an elastic network interface. So consider this one like a card or something that you put in there that they access the other services, I would say outside services from this VPC. Again, so what does Elastic Network Interface do? And more specific, I won't go into details, but it is a tool through which you can access other services outside the VPC. So in the service consumer VPC, we always have ENI or Elastic Network Interface, and then into the service provider VPC, we always have a network load balancers. It cannot be in other way around, right? We cannot have a network load balancer in service consumer VPC in order to have a private link. So whenever you wanted to access something from another service, so the provider VPC will have the network load balancer, the consumer VPC will have the private link in there. So it goes from this EC2 through the private link, through the network load balancer, and the network load balancer is going to divide the content to the different EC2 instances, right? So this is what a private link is. So you have ENI, in consumer VPC, you have network load balancer in provider VPC, and always the traffic has to initiate from the service consumer VPC, which has the ENI in it, and then reached out to the service. So it cannot go the other way around. It has to be from here, from consumer VPC into the provider VPC. Now we go through another concept, which is the endpoint interface, right? So again, if you wanted to, I would say, access certain services within the AWS, right? How do you do that? So we have two different concepts. We have an endpoint interface and we have an endpoint gateway. Again, similar to NAT Gateway in NAT Instance, when it has the gateway thing, is being, I would say it's being managed by AWS, right? So we have the endpoint gateway, it's being managed by AWS. You don't have to worry about the management, patching, and kind of updating and everything. AWS is doing that. But if it's an interface, it's kind of, you can customize it and you can configure it in certain ways that you want to do that. So now, like, what's the difference? So if there's a DynamoDB and an S3, it always use an endpoint gateway. So strictly endpoint gateway is only used for DynamoDB and S3. Again, DynamoDB is a database or a storage, right? And S3 is like a block storage. This is more kind of like a database thing. And this is where you have, I would say, item more organized and structured. Sometimes it can be unstructured as well, but like compared to S3 kind of can hold everything. And S3 can hold even a static website, and it can hold, for example, your photos and everything. Like S3, I have an interface where I'm uploading my own personal photos into S3. So the S3 can hold any kind of information in there. It's kind of like called, I won't go into details because that would be too much, I would say, at this point. And then if you have something, I would say, other than DynamoDB and S3, like Redshift, SNS, Lambda, so those are again other services. We will talk about them later, but imagine those are other services in AWS. You wanted to access them from a VPC. How do you do that? You do that through the endpoint interface. So one way is what can happen is like if anything, the EC2 instance wanted to access the Redshift, one way can does that is go through the internet gateway out into the internet into the Redshift. That's possible. But if you wanted to make it more faster, what you do is you simply add your interface endpoint, then it is within AWS network backbone. It's much more faster, more secure. And this is how you're going to be reaching out to them. So from the endpoint interface into those different services, from endpoint gateway into the DynamoDB and S3 specifically. And then what else do I have? Oh, the concept of the router in the internet gateway. I think so I was going to like mention it somewhere here, which I didn't, but actually traffic coming from the internet gateway always have to go through the router, and then the routers have the route tables, and then has the information how to route the traffic from the internet to the services inside of VPC. So that's what I have. Okay, so in terms of like what a DynamoDB is, you can consider that a secure storage in our castle analogy, and then S3 can be like a public storage. Again, S3 can become, I would say, private as well if you choose to select to make it not public, right? And then what else do we have? Let's see. Okay, so this is the concept like how endpoints can look like. So S3 in DynamoDB, you go through the gateway endpoint, and then any other service you go through the interface endpoint. And for the private link, it's kind of like a bit bigger, I would say, image as compared to what I had before, but it's again service consumer VPC, service provider VPC. You have network group balancer in here. You have your ANI service consumer VPC, and then between you have private link. It's more secure and more faster. So for this part, I think so I might be left for let's say 6, 7, and 8. I have 2 more parts. How much time do we have? I have another 20 minutes. I have to leave by 7 p.m. So let me continue with this. I hope I can finish it in 20 minutes. Okay. I would say let's just take a break. So by break, I mean, I'm going to share a little bit about like how I'm studying for AWS. So I have my background is like I did my bachelor's in psychology and neuroscience, and then I did my master's in business, did the MBA program. And I was working on my fintech startup, and then that's where I would say my interest developed, learning cloud computing, kind of like building the backend for any technology, for any kind of technology. So what was for my startup, I was working or we were working on kind of building a mobile banking app, and then so my co-founder in CTO, he was doing like the networking, I would say that the backend. And he was using AWS, and that's where I was like, okay, let me see how it looks like. And afterwards, I find that this is something I'm really, really interested to work on it. And yeah, that's how my interest developed into it. I have no background, I would say, in computer science, or I would say cloud computing or anything. Has been my first introduction to it, right? So in the past few months, I have cleared my 2 certificates. And then now I'm up to finishing off my 2 other ones. So I'm still working to get my SA Pro in networking specialty, right? So the reason, like, this is a way of me preparing for it. So like if I'm teaching it, this means I'm actually preparing well for it, right? So it was like, it's really, really hard for me to learn everything. In a way that I'm able to clear the exam. So I'm doing like the practice exam, and in each one I'm getting like 68%. I have never reached 70% up to this point for SA Pro and networking specialty. So like 75 is like, if you get 75, then that's how like you're able to pass it. But anyways, that was like a little bit tip. It's hard. It's really hard. Especially for people like me who is starting from, I would say, ground zero. But if you really love it, you can do it on this. So for me, I really like it. That's why I am even taking the time to kind of share my learning experience and teaching it to others in case someone needs some kind of, say, tips or tricks for AWS. Anyways, so happy learning, anyone doing it. Let's go next. So what we were covering for this part is, I would say, VPN and direct connect, transit gateway, direct connect gateway, and VPN client. So the bigger concepts, you wanted to connect your, I would say, your corporate data center to your AWS network. How do you do that? So just moved my, let's say, castle a bit up there, added corporate data center, and then added some databases into there, just added some another VPC, a private subnet, just looking here. And then if you wanted to connect this VPC in this region to this corporate data center, how do you do that? You do, number one, do that through the direct connect, right? Or you do that through the VPN, right? So if you wanted to talk about the direct connect, how it's going to work. Usually there is a direct connect location, right? And then in that direct connect location, you have something called a direct connect or DX router on the AWS side, a customer router on the corporate data center side or the client side. And then what you do is you connect a DX router with a customer router, and that's called cross connect. And then you connect this customer router to your corporate data center through the customer gateway. And then you connect your DX router to your VPC through private WAF, right? And then on the VPC side, you have virtual private gateway. So there was too much in here. So basically, if I'm a client sitting and I have an AWS account and I wanted to order a direct connect, what I'm going to do is I go to my AWS console and I kind of look up for different direct connect location. So these places are actually provided, these locations are provided by the third party. So they have those connections in place already. And then what you do is you look up for some direct connect location providers closer in your region, reach out to them through your console, and then you say, I wanted to have this direct connect connection. And then that's how it works. Like I won't go into details for this video, like how it works, but basically I'm going to be talking about the architecture, right? On the AWS side, on the VPC side, you have virtual private gateway. On the corporate data center side, you have the customer gateway. In the direct connect location, you have direct connect router, and then you have customer router. Both of them are connected through the cross connect, and this part is called direct connect location. And then from direct connect DX router to the virtual private gateway, it goes through something called private WAF. So if it goes to a VPC, it's going to be a private WAF. So WAF stand for virtual interface function or something like that. I don't remember that, but anyways, it doesn't matter at this point, right? What it means is, so WAF is securely connecting to a VPC is you use a private WAF. If you want to reach out to a public service like S3, then you will be using something called a public WAF, right? So if it's a EC2 instance with a public IP, or if it's an S3 bucket, or if it's a DynamoDB, so it's not a VPC, then it's a public WAF, right? And then if you so it's going to be a public WAF, but if it's a VPC, then it's going to be a private WAF, right? So now what if the consumer VPC wants to connect with a corporate data center, right? So this is our consumer VPC, and this one wants to connect to the corporate data center. How it's going to do that, right? So let's see. It's going to do something. So you can see I'm adding a few stuff in here, right? But before I do that, so we have this private link already connected. So we had this, I would say, this private subnet here. It has an EC2 instance, it has an ENI, and then in this VPC, the VPC that's connected through the direct connect to the corporate data center, we are adding a network load balancer, right? So now this one becomes a provider VPC, right? Similar to this one, when we had a network load balancer into this VPC, it become a provider VPC. Now, if we added a network load balancer here, now this one become a private, I would say a private, not a private, a provider VPC. So No, now this consumer VPC through this private link network load balancer, the specific VPC is reaching out to the corporate data center. So the consumer VPC is accessing the on-prem or on-premise data center via the private link, but over the VPN or DX connection. So it's not doing that directly. What it's doing, it's actually, so this VPC, since it's already connected to this corporate data center through the direct connection, that's how it puts a network load balancer in here and connects to the corporate data center. Okay, so now let's talk about the VPN, right? So for AWS VPN, we have a virtual private gateway on the AWS side, and then we have again a customer gateway on the corporate data center side. And this is how we have two, since there are two arrows, it's been there are two different tunnels. For VPN, we usually have two tunnels for redundancy, right? So like if one tunnel goes down, then you have the other tunnel up there, right? So for the difference between a direct connect and a VPN is direct connect goes through a dedicated route between AWS network and corporate data center, but for the VPN, it goes through the public internet, but the traffic is being encrypted, so no one from the outside can read it, what's happening or what's data is being transferred from this one. So if there is a third party trying to reach out the content that's being transferred between AWS and corporate data center, they cannot do it because the traffic is being encrypted. But in case of direct connect, it has a dedicated route between data center and then AWS. So it's not being encrypted. So the traffic that goes through the direct connect is not encrypted, but for the VPN, it's done. But what happens to the VPN is through public internet, AWS is through a dedicated route. So that's again like the basic difference between them. Let's see what else we have. Yeah. And now, if you want to, this data, I would say a data center wanted to reach out other AWS services like Redshift, SNS, and S3, it can actually do that over the VPN or over the DX through the endpoint interface, right? So there is a server sitting in this data center, wanted to reach out to Redshift in here. What it does, it goes through the direct connect or through VPN to this endpoint in this VPC, and then up to the Redshift. So this is how it works. Okay, so let's see. Yeah, so it goes through the VPN DX. And DX stands for direct connect. So that's how it works. Okay, so now let's do something. Since this direct connect location and then this these VPCs are in the same region, which is region 2. You have the same, I would say, the same, yes, your direct connect location and your VPCs are in the same region, it works. But how about if the DX location is in a different region? Can you access that through a private web? So that's where it cannot work. So if they were in the same region, we were using private web and easily we were able to access this VPC. But what about if this VPC wanted to be reached out through this corporate data center or maybe like another corporate data center? How does it work? Can a WIF work? No. At that point, a private WIF will not work. And then that's when you have to add a direct connect gateway, because the direct connect gateway leverages different regions. So now, so this is one region and this is another region, right? So this corporate data center or another one through the direct connect gateway can be connected to this location, to this region, and then through this region through the private web, right? So that's the basic thing. So I'm just adding another direct connect location, just adding another corporate data center, and then now this corporate data center through the customer router, through the DX router, through the private web, and then it's reaching out to this VPC in this region. Okay, so I think so you did get the point. So a private web in the same region, direct connect location, and then VPC in the same region, private web does work, but if it's a different region, then private web will only work if you're adding a direct connect gateway in there. So now I added the concept of a transit gateway. So I removed my castle because at this point, I would say it's not as useful as it was in the early parts of this concept. So let's go with this. So I'm adding some transit gateway, right? So let's see what the transit gateway is meant and what is going to do. So I added just a few more regions out there, and then I added some more VPCs in there. And then what happens is now, if you want to connect these VPCs, all of them together, so VPCE can talk to this VPC, and this VPCE can talk to this VPC, and then to this VPC, not to this one, because no, the one that directly connected. So this VPC, and this VPC, if they wanted to talk to each other back and forth, they can do that. So like they can even talk crosstalk. So this VPC can talk to this one, even if they're not directly connected, but since they're connected through the transit gateway, they can talk to each other. So that's, and also for these VPCs, right? So you have VPC B, VPC C, and then this VPC A. All of them can talk to each other, and that's the purpose of a transit gateway. Okay, so a transit gateway is meant to connect different VPC, and then, excuse me, these VPCs can talk to each other. So this is how it works. Okay, so let's see what else we can do in here. What's happening? Okay, so whenever you have a transit gateway, right, and then you wanted to reach out to the corporate data center, it's going to do that through a transit web. Yeah, I'm sorry, guys. I had to clear my throat, kind of like the end of the day for me. And my coffee almost kind of finished. But anyways, I think I have a little bit more time and a little bit more content to cover. So what we dropped in here was a transit WIF, right? So for direct connect, we have three different types of WIF or connections, right? So you have the public WIF, you have the private WIF, and then you have a transit WIF. So whenever you have a transit gateway, you are using a transit WIF. You cannot use a private WIF or a public WIF. For transit gateway, you do have to use a transit WIF. That's how I have it in here. So you have a transit WIF from this direct connect location to this transit gateway, and then these VPCs. So now, all of these VPCs connected through the transit gateway, through this direct connect location to this corporate data centers, they can talk to each other back and forth. Okay, and then let's see what else I have. So I'm just adding the AWS client VPN in here. So a client VPN is basically if you have an employee and they wanted to reach and they wanted to work from home, but they have to access your corporate data centers, then you wanted to give them kind of like a specific or certain VPN connection. That's how it works. I won't go into details, but it's different than a site-to-site VPN. So this is like connecting your data center to AWS is kind of a site VPN, but AWS client VPN, when you have your client, I would say like an employee trying to reach out to corporate data centers, and then from corporate data centers connecting to the AWS, they can use an AWS client VPN. So I think so, yeah, that was part 6. My next part is going to be, again, VPC peering in a bit more on the transit gateway, which includes transit gateway peering and then transit gateway route table. So transit gateway is a huge topic. We're covering just the basics of it in here, but I hope it can make sense. So this is where we left off in the previous part. So I'm just adding some more public and private subnets into my VPCs. And then what I'm saying is that this is a spoke VPC, then this is a centralized VPC. And by that, I mean, these VPCs through the transit gateway can talk to this one and then out into the internet, right? And then what I'm doing is I'm adding some, I would say ENI, so Elastic Network Interface, right? So, and then in these private subnets, usually what happens is when you're using transit gateway, then you use a specific, I would say, a reserved subnet, and that's used for this ENI. So you get a subnet reserved for ENI, you put an ENI into that, and then that ENI is connected to the transit gateway And from there, you wanted to reach out to the internet. So see how this works. So you have, I would say, your spoke VPC here, and another spoke VPC here. You have your EC2 instance. There is an ENI. So in this one, I haven't put a separate subnet, private subnet for the ENI, but just for the sake of space. But you get the point. So whenever you're putting ENI, it's a good idea to give it a separate subnet. So from EC2 instances into the subnet, into the transit gateway, and the same for this one, it goes through the ENI subnet of the centralized VPC. And from there, it goes into the NAT gateway. You remember in here, we talked about the NAT gateway. It is for outgoing traffic, and then out into the internet gateway, and then into the internet, right? So this is how it works. The purpose of a centralized VPC is like you have only one NAT gateway, right? Say this VPC wanted to reach out to the internet, it needs to get like a separate VPC, and then it has to have like its own NAT gateway, and then this one have another NAT gateway. It will be too much and too like it will be like I would say more complex architecture. The easy way is to have a transit gateway and then get a centralized VPC connected to this transit gateway. So now I have like two VPCs. They can be like multiple 20, 100 VPCs, right? All connected through a transit gateway, and then you have one centralized VPC that you go through the internet. So if you wanted to have multiple VPCs talking to the internet, you get a centralized VPC, you put an ENI subnet in here, you put a NAT gateway in the public subnet, and then out into the internet. And one thing I think so I forgot to mention, always and always your NAT gateway, NAT instance in your Bastion host, right in here, they have to be put in the public subnet. I think it's obvious because if you wanted them to be talking to the internet, they have to be publicly accessible. That's why they are in the public subnet. Okay, and now what happens is if your transit gateways are in two different regions, they can also be connected with each other through the transit gateway peering, right? So now this transit gateway in this region and this transit gateway in the separate region are connected to each other. And then we talk about like something called the transit gateway route tables, right? And then for that to understand, I'm going to put my face down here. For that to understand, I'm just adding some more VPCs with some more, I would say, CIDR ranges or IP ranges, right? And then I'm adding another VPC. Now you understand why, right? So, and then we have now, since these VPCs are connected to this transit gateway through different attachments. So if it's a VPC M, so it's attachment M, VPC N, attachment N, VPC P, attachment P, right? And then what happens is, if you see in here, right, you have the 20/16 VPC, which is VPC P. It goes through the attachment P. It's really small, but let me just do something quickly here. I wanted to make it a bit bigger so you can see what I mean. So here. So this is the route table for the transit gateway. So, and then these are its attachments. So we have different VPC. If it's a 20.00/16 VPC /16 attachment, it goes through the attachment P to this one, which is the specific VPC. If it's a 30/16, it goes through the attachment M to this VPC. 40/16, it goes through the this VPC. So this is how the route table for a transit gateway works. So what I'm going to do is go back and make my full screen. God, it went so small. Anyways. Okay, so this was the concept of, I would say, a transit gateway. So you saw this thing appears, the VPC peering, right? So now let's just talk about, so I did talk about the transit gateway first, right? And then I talked the VPC, but usually the purpose for both of them is to connect VPCs together so they can talk with each other, right? So instead of connecting to the internet, excuse me, and then to this VPC, for example, this VPC can connect to this VPC through the internet, but that will be like really kind of, I'm not sure, let's say more cost and more complex architectures compared to when you simply connect the two VPCs together, right? So both VPC peering and then transit gateway act the same thing, but there is some benefit of a transit gateway over VPC peering. Let's just understand that, right? So I'm adding another VPC, right? And then what happens is like this VPC wanted to connect to this VPC. Usually the first VPC who wants to make the connection is a requester VPC. And then the other VPC which has to accept that request is an acceptor VPC, right? So now these two VPCs are being connected, right? So if I say, can VPC H talk to VPC I? No, they cannot do that because it's only these two that are connected, right? And then if I have another VPC, say another region, and now this VPC in this region is being connected to this VPC in this other region through the VPC peering. Can I say that this VPC can talk to this VPC? No, they cannot talk. If it was a transit gateway like this one, so all the VPCs, for example, this transit gateway connecting all these VPCs together, they can talk to each other because this VPC, this transit gateway and this transit gateway are connected, and these two VPCs are connected to this transit gateway, and all these VPCs are connected to this transit gateway. Now all these VPCs can talk to each other. But in terms of the, I would say the VPC peering, it has to be direct one-to-one connection, then they can talk to, otherwise there is no transitive routing. That's why a VPC, that's why we have a transit gateway that allow for transitive routing. But if it's a VPC peering, there is no transitive routing. For example, this VPC tried to connect to this one, cannot do this. VPC wanted to connect to this one, no, it cannot do that because there is a VPC peering, not a transit gateway. So I think so we did cover quite a part in this one. We talk about the direct connect, the VPN, the direct connect gateway, the transit gateway peering, the VPC peering, and also we talk about the transit gateway route table. Okay, so I am coming toward the last part. I really hope I'm covering that within my timeline. I hope it's not really late. But anyways, I will try my best to make it as fast as I can because I really have to rush on too. So I'm adding, I'm putting my face now here because that part is not being used anymore. So I'm just adding another corporate data center here, right? So let me just go a little bit quick back to my last part just to see what I had to cover. Okay, so for this one, what we're covering is common connectivity scenarios between corporate data centers and VPC, load balancing between the paired VPCs and on-prem data centers. So we wanted to know how the corporate data center can connect to these VPCs and how we can load balance the traffic between the VPC and then the corporate data center, right? So that's why I'm adding a corporate data center here with some data centers, and I'm connecting these VPC to the corporate data center through a VPN. So you already know what a VPN does. Excuse me. And then I'm adding like another VPC with a NAT Gateway Internet. It's like the same setup that we had in here. And then I'm adding a VPC gateway endpoint. It's similar to what we talked about here in connecting Genesis 3 and DynamoDB. And then let's see. Okay, so what I'm trying to say in here, so if we have a scenario where we have a VPC here, and then this VPC wanted to connect to the internet, right? So it doesn't have any other connection out to the internet other than this one. Like ignore this part that this is connected, this transit gateway is connected to this transit gateway, and this is out connected to the internet. Imagine there was no this transit gateway peering in here. And then you can see this transit gateway doesn't have access to the internet at all. Yes, it has connection to the corporate data center, but it doesn't have connection to the internet. It has a VPC peering to this one, right? So I can imagine, I can say, oh my God, okay, so I have a connection, like a VPC peering connection to this gateway, to this VPC, and this VPC actually have access to internet, right? So can I imagine that my VPC can reach to the internet? No, it's not possible, right? So if it's a VPC peering between the two, I would say, to VPC, since VPC peering is non-transitive in nature, it cannot give us access to the internet through a NAT gateway. and then also through the internet gateway out into the internet. So that's not possible. So that's one scenario, right? Another scenario would be, can it access that through the VPC endpoint gateway to reach out to these S3 and DynamoDB? No, it cannot do that one either. So can it go through the NAT gateway into the internet? No. Can it go through a VPC endpoint gateway to access services within AWS network like S3 and DynamoDB? No, it cannot do that either. And that's meaning we're talking about like this peering. Since we have this peering, VPC peering connection, can those things happen? And we can see that they cannot happen. How about if this VPC wanted to connect to this corporate data center? Just because I'm thinking that these two VPC are connected through this peering connection, and then now I have a VPN, site-to-site VPN between this VPC-P and this corporate data center. Can I assume that my VPC can access this VPC? No, it cannot do that, because again, since this VPC peering is non-transitive in nature, that thing cannot happen either. I know this thing might be a bit confusing, but just think about this one, I would say. Think the VPC peering. So the VPC peering is the main culprit, I would say, and it's not allowing anything to go either to the internet, to AWS services, or to corporate data center, because it's not transitive in nature. If that was a transit gateway, that might have been possible. So those are common scenarios between the VPC and then the corporate data center. Now I'm talking about the load balancing, right? So I'm adding something called, like this is an application load balancer. So application load balancers have two types. One is kind of like an internet facing, and another one is internal. So internal is for any load balancing within the VPC, and then internet facing is when you wanted to connect to other VPCs here, and then wanted to connect to corporate data center, things like that. So you can see like I have a public subnet. Within that public subnet, I have internet facing ELB, and then I have an internal ELB in here, right? And then I'm adding some private subnets with some EC2 instances in there. And then you can see what I had. I had a target group 1 here, a target group 2 here, and then a target group 2 here in my corporate data center. So I have a corporate data center here, I have this VPC here, and then I have a separate VPC. So now any traffic that will be coming through this internet facing ELB or application load balancer, it can be divided to these 3 different target groups. So one, this is second in corporate data center, and third one in this other VPC. So this is how the application load balancers can kind of load balance the traffic through that. So there's like a user trying to reach out to this internet facing ELB. So now it's sending the load balancing across the peered VPC. And the reason that it can do that is because through this peering, right? So now this peering, you have an ELB or application load balancer wanted to reach out to this, I would say like in this target group is actually a set of EC2 instances. Like for this target group 1, I have added some EC2 instances, but I haven't done that for this one, just for the sake of space. But usually for the application load balancers, you put some EC2 instances and kind of name them a certain target group, and then you're sending traffic to that group. It kind of divide all the traffic within those EC2 instances. So you have target group 1, group 2, and group 3. Through this one, it does it because of the VPN connection. So it's load balancing across on-prem through VPN DX, load balancing through this one through the, I would say, across a peered VPC. So what happens is, again, we know that the VPC peering connection has non-transitive in nature. So this thing cannot go outside to the internet, or I would say to some other VPC just because they're connected, but they can, since they're directly connected with each other, that's how these two can work, right? Okay, so let's see what else do we have. Okay, so we have the internal ELB, right? So for example, if you wanted to kind of load balance the traffic between the private instance, the private subnets, then that's where you will be using internally. Again, this might be a bit more complex topic, so I wouldn't go much details into it, but this is basically what it is. And then here I'm adding just a route table for this VPC, right? So we had another route table here, but this is a bit more like we have some different, I would say, concepts in here, right? Not concepts, but different routing. So for example, if it goes to, if the destination is a 20/16 thing, which is this VPC, it's local, everyone can talk to each other. If it's meant for the internet, then it has to go through the virtual private gateway, right? And the reason that I'm saying that is, kind of like this is my virtual private gateway, so it has to go through this one, and maybe this I would say corporate data center is being connected to the internet, and that's how it wanted to go through the internet, right? And then I have another thing that's 30.00/16, and it has to go through the transit gateway. So like this 30, let's just find out who has a 30 VPC range, CIDR range. So this VPCM has that range. So any traffic that this VPC wanted to send to VPCM, it has to go through the transit gateway and then into this one. So I just added like the transit gateway concept in here in the virtual private gateway. So for this one, we had like local internet gateway, Bastion Host. And then in this one, what we have is actually, I would say the virtual private gateway, and then the target, the transit gateway. And in this one, I think so I did miss to mention that in this one we have a Bastion host, right? In this one we have a NAT gateway. So if it's meant for the internet, for this one, so anything that's originating from the web server, from the database, and that's meant for the internet, it has to first go through the NAT gateway and out into the internet. But if it's kind of like coming inside this specific web server, then it has to go through the Bastion host. Okay, so excuse me for that, just clearing my throat again. Okay, so what else do we have? Let's see. Yeah, so what happens with like this transit gateway through this AWS site VPN through a virtual private gateway can also connect, not virtual private, customer gateway can connect to the corporate data center. So we have virtual private gateway on the customer side, or on the AWS side, and then the customer gateway always on the corporate data center side. What else do we have? I think so that was pretty much it. So I don't have more stuff in there. So thank you so much again. If you have any questions, please let me know, either in the comment area, or I will be leaving my contact information too. Again, I'm going to make this confession at the end of this video too. I am not I would say an expert or a teacher on AWS. I'm just a student learning it myself and trying to share my learning ways with other students. If I'm making any mistakes, please let me know. Any feedbacks or suggestions are more than welcome. I will let you guys have a beautiful day, if it's day or if it's evening or night, and enjoy your time. So that's it. It's almost 7:15. Oh my God, I think I will be getting late. I have my sister with my little cute niece who have come over, and I don't want it to be wasting time. I want to spend some time with them. So I have to run, and then again, wish you guys all the best.